warahmatullahi wabarakatuh. Saya Hanisa binti Azman Shah. Nombor Kementrik D20141066076.
Nama saya Cik Nur Azmah binti Cik Omar. Nombor metrik D20141660084.
Nama saya Siti Nafazlin binti Mak Bahrudin. Nombor metrik D20141068492.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Rasha Fitra binti Muhammad Rijal. Nombor metrik D20141066072. Tajuk yang kami pilih untuk presentation ini adalah thread issues.
Threading issues. 1. The fork and exec system calls. 2. Signal handling. 3. Thread cancellation. 4. Thread local storage. 5. Scheduler activation. The fork and exec system calls. The semantic of the fork and exec system calls change in a multi-threaded program. If one thread forks, is the entire process copied, or is the new process single-threaded? 1. System dependent. 2. If the new process exits right away, there is no need to copy all the other threads. If it doesn't, then the entire process should be copied. 3. Many versions of Unix provide multiple versions of the fork call for this purpose.
Threading issue. Threading issue in signal handling. What is signal handling? Signal handling is software interrupt delivered to a process. The operating system uses signal to report exceptional situation to an executive program. Some signal report errors such as references to invalid memory address. Other report asynchronous events such as disconnection of phone line. Question. When a multi-threaded process receives a signal, to what thread should that signal be delivered? There are 4 major options you can use in signal handling. First, deliver the signal to the thread to which the signal applies. 2. Deliver the signal to every thread in the process. 3. Deliver the signal to the certain thread in the process. Lastly, assign a specific thread to receive all signal in process. The best choice in signal handling may depend on which specific signal is involved. Unix allow individual threads to indicate which signal they are accepting and which they are ignored. However, the signal can only be delivered to one thread, which is generally the first thread that is accepting that particular signal. Unix can provide two spread system called kit and pthread for delivering signal to process or specific thread respectively. Windows do not support signal, but they can be emulated using a kernel's produced core that are delivered to a specific thread, not a process.
Thread cancellation. Thread cancellation involves terminating a thread before it has complete. For example, if multiple threads are concurrently searching through a database and one thread returns the result, the remaining threads might be cancelled. Another situation might occur when a user presses a button on a web browser that stops a web page from loading any further. Threads that are no longer needed may be cancelled by another thread in one of two ways. Asynchronous cancellation, which is cancels the thread immediately, and deferred cancellation, which is set of flags indicating the thread should cancel itself when it is convenient. It is then up to the cancel thread to check this flag periodically and exit nicely when it sees the flag set. Another issue of thread is thread local storage. Threads belonging to a process share the data of the process. Most data is shared among threads, and this is one of the major benefits of using threads in the first place. However, sometimes threads need thread-specific data also. Most major threads libraries provide support for thread-specific data known as threads local storage or TLS. Note that this is more like static data than local variables because it does not cease to exist when the function ends. For example, in a transaction processing system, we might service each transaction in a separate thread. Furthermore, each transaction might be assigned a unique identifier. To associate each thread with its unique identifier, we could use thread local storage.
Okay, for the last thread issues is schedule activation. Many implementations of threads provide a visual processes as an interface between user and the kernel thread for many-to-many or two-tier model. Okay, this visual processor is known as a lightweight processors or LWP. There is a one-to-one correspondence between LWPs and kernel threads. The number of kernel threads available and hence the number of LWPs may change dynamically. The application user level thread library maps user threads onto available LWPs. The kernel threads are scheduled onto the real processors by the OS. Okay, the kernel communicates to the user level thread library when certain events occur, such as a thread about to block via an upcall, which is handled in the thread library by an upcall handler. The upcall also provides a new LWP for the upcall handler to run on, which it can then use to reschedule the user thread that is about to become blocked. The OS will also issue upcalls when a thread becomes unblocked. So the thread library can make appropriate adjustment. Okay, if the kernel thread blocks, then the LWP blocks, which blocks the user threads. Okay, ideally, there should be at least as many LWPs available as there could be concurrently blocked kernel threads. Otherwise, if all LWPs are blocked, then user threads will have to wait for one to become available. Okay, this is the lightweight process LWP, which occur between user threads and kernel threads.